Hey everyone, so here's my 2014 Focus ST. I'm going to be taking the transmission out of it, replacing the clutch and the flywheel with a lightweight flywheel. I'm also going to be tearing open the transmission and putting in a Wavetrac limited slip differential. I'm not going to show you everything. I'm going to start by taking all the stuff up here out on top. You're going to have to take this cowling out, the wipers off, airbox battery, intake, and then there's a bunch of stuff underneath the car that you also have to take out. I'll show you some of those things as well. The thing I'm primarily going to show you though is on how to open up the transmission and set the correct differential preload. So stay tuned. Okay, so here's everything I'm going to be installing. I got a new Wavetrac limited slip differential. I have an OEM clutch from Ford. I'm putting in a spec lightweight flywheel. Other things that you'll need is thread locker, gasket material, thread sealer. You'll need flywheel bolts. You need the bearings. You need some new axle seals. I have a whole bunch of shims. These are the preload shims. I got all the even and odds from something like 1.4 all the way up to 2.10 millimeter. Also the measurement shim, which is 1.10 millimeter. You got a new slave cylinder, clutch alignment tool, some odds and ends. This is the cap that goes over the half shaft. Intermediary bearing, some new bolts for the ball joint, and there's some more bolts. Also a flywheel holder, so when I can torque the flywheel bolts. So right now, I've got the car up on all fours. Should have plenty of room to get the transmission out. I've got the engine supported with this engine support bracket from OTC. There's these loops right here that you put in and supports it pretty firmly. And so what you use is this. What will probably happen is I'll have this over here, and then you can raise and lower the engine once you get the transmission unbolted down here. The transmission is not terribly tight, but you do have to kind of wiggle it out of there. Once you get to that point, I'll show you my setup. So now I got the wheels off. You have to take out this fender liner. I got most of the bolts out on that, so I'm going to take that out next. You're going to have to take out your axle nut, and then you have to take out your ball joint. So this is a T55 Torx, and then I think 15 millimeter on the other side. So that will allow you to get your driver's side axle out. That one has to come out completely. And then you'll have to take out the charge pipe. This torque strut. And then over there on that side, you'll have to break the control arm free again, and that'll allow you to get the axle out from that side. But you don't have to take the nut out on that side, because once you get that center support bearing off, it should just come out, and then you can just tie it out of the way. The other thing to note, the drain plug is right here. If you don't want to get oil on your subframe, just put a piece of cardboard there. I believe this transmission takes 1.8 liters of that dual clutch transmission fluid. So I'm going to get these axles out, everything out of my way, which will then allow me to support the transmission with a jack, and then I can start loosening the bell housing bolts. So I finally got the transmission out. It's coming out pretty smoothly. The biggest thing I say is here is you're gonna have to push it back up to the frame rail here, and then just slowly keep on lowering and pulling away from the engine at the same time. The hardest part will be to get over this frame piece, but this this jack here that I got from Harbor Freight works really well because it just articulates up and down. You can move it around really well, and it has this strap. So I mean, everything felt really secure. It's probably the easiest that I've ever had a transmission come out. So the next steps, I gotta finish moving that out, and then I'm gonna be replacing the clutch and the flywheel. So one of the things you have to really pay attention to when you're pushing these bearings on is, if you can see this shaft right here, this is the differential, and then when it splits that gap right here is the bearing, the tapered roller bearing. And if you see ever so slightly, it is pushed below the differential. If you're using a socket to push this on, it'll end up being level with this, but it has to be recessed ever so slightly. And the way that I did that was just using an old piece of exhaust tubing and lining it up on this inner race right here. And make sure also when you're putting these on, one side will be easy, but then when you go to flip it over, now you're going to be resting it on this bearing side. So make sure you're supporting it from the center here. Otherwise, you could damage your bearing. So you see here, now I got the transmission cracked open. Be careful when you're opening this. There's these lugs here and here. If you get under these with a punch, they can help a lot in separating the case. So one thing to know is these bearings on the output shafts are the same that are on the differential, which means the preload shims on the input and output shafts are also the same as the differential. Now, when you go to get these races out, I highly recommend getting a slide hammer like this. Let's see if I got the part number for you. This is OTC. This made the race just came right out. It wasn't even hard. For getting out the seal, get a seal driver. They'll come right out too. So now I'm going to be swapping over the ring gear onto the new differential, and we'll be doing our preload shimming. So this was the one that was in there. This measures at 1.734. I mean, I got a whole bag of shims. It sucks because if you want to do this in one weekend, you kind of have to have all the shims on hand. If you let your car sit for a while, tear it apart, do your preload measuring, and then just order the correct shim that you want, probably be a lot cheaper. But the cool thing is, since these preload shims are the same, now when I go to rebuild this transmission with better synchros, I already got a ton of shims to choose from. Alright, so I'm going to get everything swapped over, and I'm going to show you how to measure the preload next. So now I got the preload shim in there, which is 1.10 millimeters. It's in the bell housing side. When you're putting these races in, use a heat gun and then just go around. You should not have to pound these races in. They should just fall right in. Likewise for getting them out. If you just have the tool that I showed you, which is it's a pilot bearing puller tool, you grab in underneath this slot and that cylinder there and just hit it once after it's been heated up, and that race should just come out like it doesn't even belong there. But what happens when the aluminum cools down, the metal contracts around the race, and then it's in there. So don't try to take these out without heating them up. I mean, you can get them out, but you're just gonna cause yourself a lot of frustration, especially if you don't have the slide tool. You know, this thing I showed you. This thing makes it super easy. If you don't have a slide hammer, then you have to come from this side and kind of catch it under here, and you run the risk of damaging this surface here. So highly recommend heat gun, slide hammer. Okay, so I'm going to put the differential in. I have the new bearings on here, and there's one on the bottom here as well. The thing to note, I think I already mentioned this, is that this bearing does not sit flush with this center part right here. It sits slightly below that. So if you're using something flat and you can't get it down below that, you're going to get the wrong preload reading. So I'm going to place this into the transmission. You want to be careful. You don't want to damage your races. And the next thing, I'm going to put the case in. And you have to be careful with this because we have our alignment pin here. We have our oil slingers here. These are plastic. They're extremely delicate. We have two things that align in here. I think those are the shifter rails. And we have our input shaft steel here, so you don't want to damage that and cause your transmission to leak. What I've already done is I went and cleaned the gasket surface. These are a plain surface, so don't gouge them or anything. They're extremely parallel with this other side of the case. Once I get this on, we're going to put some bolts in and torque those to the specifications and then measure bearing preload. Right now I have the new race in here with the measurement shim behind it, which is 1.10 millimeters. Anything can be your measurement shim. You just want it to be of a known quantity that's less than what the total preload will be. So we got to leave some space in here between this race and this race that's in here. We leave that gap in there so when we push up on the differential, it's going to show us that leftover space, and then we can calculate the preload off of that. So I'm going to go ahead and put this together, and I'll be back to you shortly. Okay, so this is my setup. I have the ratchet strap just to hold the transmission to the table. It's bell housing up. I have a metal plate here that's bolted with two of the bell housing bolts. That way it gives my magnetic base something easy to grab onto. I have the digital dial indicator on the inside of the differential. So if you see inside here, it goes straight up and down. So this is going to show us the movement of the differential. So I'm going to push from down here. I'm going to push up. Gravity is helping us right now, so everything is shoved down. That means up here, there's going to be a little bit of a space, and that's the space that we're measuring. When we push up, that space is going to close, and it's going to push up on the dial indicator. And that's going to give us the distance that's left between the differential bearings and the case itself. Now we have a measuring shim in here too. It's 1.10 millimeter. So what we do is we measure, we take 3 measurements, we take the average of those. We add that distance that we measure here to the measuring shim. So the measuring shim is 1.10, so let's say this comes up to be 0.3. We add that to 1.10, which would mean that would be 1.4. That means that their total distance without the measuring shim in here between the bearing race and the case up here is 1.4 millimeters of distance. And then Ford wants an additional 0.2 millimeters of preload. That means that you're now adding more distance between in between the races of the differential. That means it's going to really press down on the bearings this way. And the reason why you have to do that is because these are tapered roller bearings, and tapered roller bearings require a preload because tapered roller bearings want to walk away from each other. So you need to put a lot of pressure on them because they're handling axial and horizontal loads. So I'm gonna go down here and push up on it, and you're gonna see the dial indicator. This number will go up. So I have it zeroed. I also have some distance here, so to make sure that it can move freely up and down. So here we go. So you see here I'm pushing up on the bottom. We have 0.33 millimeters of gap. So now I'm going to turn the transmission, which is going to I'm going to turn the input shaft, which is going to turn the differential, and then I'm going to measure again. So we want 3 measurements. So now I turned the transmission about 90 degrees, or the differential about 90 degrees. And you see we got 0.33 again. So here, one of the problems I have is that when I zero it, my hand affects it. So there's still, right now at resting, it's at 0.01. So we're going to subtract that from the total amount. So we're at 0.34. So one thing, so we got about a 0.33 millimeter gap that's left in there. I have seen methods where people try to use feeler gauges to do this, but that method is really inconsistent. What you have to do with that is you don't install the race all the way. You have to let the squishing, when you bolt the case together, you have to let that push the bearing race up enough to where the differential is pushed completely against it, which will then leave your gap in there. And you might get a totally incorrect reading to do that. You really need to have a dial indicator to do this properly and pushing up on the differential. This is the best way to do it to get you the most accurate preload, to ensure that you'll have good longevity. You might get the preload around ballpark with feeler gauges, but you probably won't have the best longevity as you do with this method. So now I got my dial indicator off there. Now I need to disassemble everything, and I need to take out the bell housing side race. So again, I'm going to heat up the case to do that. Can't stress enough how important it is to have a really good heat gun with this. The bearing races, you should have no problem getting those out. If you run into resistance, that means you haven't heated up the case well enough. You could probably use propane torch too, but you just have to be careful of that because you could overheat the aluminum. Okay, so I'll do some math for you guys real quick. So our measuring shim, MS, that was 1.10 millimeter. We installed that behind the race on the bell housing side. We took the average of each measure of the 3 measurements, so it was 0.33 plus 0.33 plus 0.34, and then you just divide that by 3. It's going to be like 0.33. I mean, we don't have to be too precise about that. So then we take this measurement, 0.33 millimeters, we add it to the measuring shim, and then we add another 0.20 millimeters. This measurement comes from Ford. This allows it to squish the bearing races more and put pressure on it. It's essentially acting like a wedge. So you can add all those up, and your total will be 1.63 millimeters. Now, we don't have a 1.63 millimeter shim, so what Ford recommends is you just go up to the next size. So all the shims I have go in 0.05 increments. So I'm going to put in a 1.65 millimeter shim. And then I'm going to take out the measuring shim here, and I'm going to replace this shim. And then at that point, the transmission has appropriate preload, and it's ready to go back together. Okay, so here's our shim. It's a 1.65 millimeter. Always check your shims. I'll have part numbers for these because there's a lot of part numbers for these, and with the MMT6 manual transmission that's in the ST, they won't list the shims that are required for this, because to Ford this unit is unserviceable. Even if you buy your differential from Quaife, they just have you plop it in there on the old races, which I don't know why they would do that. That just kind of doesn't lend itself to being, for longevity. So if you want it done correctly, you need to reshim and put new races in there. So I've already measured this one before, and I know this is a 1.65. It's the other thing, they don't tell you what size it is, so I'll have all that in the description. So I got my my micrometer here, so I'm going to measure the shim to make sure that's the right size that we need. And you see it's 1.655. 0.005 millimeters is nothing. That's like tenths of a thousandth. So this is our shim. That's the one that's going to go in there. So the next thing I'm going to show you guys is I need to pull the measuring shim out. So I'm going to heat the case up to do that. Okay, so here I'm heating up the case. I have the heat gun set at 1200 degrees. And you just want to move it around. Just heating up the case. Aluminum cools off very quickly, so you got to be kind of quick to get the puller in there. Again, this race should just come out super easy. Sorry about that noise. It's going to stay like that because the heat gun is cooling down. So there's 2 lugs in here. I'll show you those in a second, but you just get in there, and you tap it, and you see how easy that's coming out. You should not have a hard time getting this out. Just be careful because this is your good race. And in here, this is your measuring shim. You see these 2 lugs here. This is for oil control. And that's where you are going to put your puller under. Again, make sure you don't hit these. These are plastic. They're extremely fragile. If you don't have a slide hammer, you can come from underneath here, and then you just use a punch like this, and you would just scoot under. You come in here, and you just get under it here, and here, and just kind of walk it off. If you don't have a slide hammer, again, you can rent these too. You can get them from AutoZone. It's a pilot bearing puller. That's all it is. Okay, so the next thing I'm going to do, I'm going to take out. This is our measuring shim. I'm going to put in our 1.65, and then I'm going to drop the race down in there, and I'll show you how easy the race should go in there after you heat it with the heat gun. Okay, so here I am heating up the case again to put the bearing race back in. I have it set at 1200 degrees. I'm just moving it around. Should take about 5 minutes of heating, maybe a little bit less. But I'm going to drop it in. You're going to see how easy it just drops right in there. But I'm also going to use the old race to pound it in a little bit just to make sure it's fully seated. So here's the new race. And see how it just dropped right in there? Should be fully seated right now. But here I'm going to use the old race and a seal driver. Just going to put it right on there. And there you go. That should be fully seated. Alright, so now I can start applying my gasket surface here, and then put the transmission back together. And after that, it goes back in the car. So I have the transmission all sealed up. I highly recommend when you're going around and you're torquing these to mark them. You want to do, because you want to do stagger. You're not going to go in a row. You're going to start like over here, and then you're going to move like over there and back and forth and back and forth. So you'll lose track of which ones you've torqued. So mark them as you go. Now we're at the step where we need to install the drive shaft seals. you really need something like this. So this set over here has a bunch of different I don't know, plates, cylinders, I don't know what you call them. But anyways, so here's the new seal. You see this little spring in here? If you just use a flat surface, like if you just pound it in with this one, if you don't support this center part right here, that little spring can just pop out. So this set here, you double up on them, and then when you put it in there, it puts a little tension on that spring, so it expands it and it won't pop it out. And then you can come over here, line it up, and then you take your hammer and that sound is when you know you're bottomed out. And then that's what it looks like installed. So here we go. I have the transmission back in. It was a little bit difficult getting this in by myself, so I had to call a buddy over to help me get it in. I got the clutch bled. These clutches can be a little bit tricky to bleed. You either have to use a vacuum line on here, or you have to use a pressure bleeder up here. You have to work the clutch back and forth to get the air out. So don't be frustrated if it takes you a little while to get that bled. I also have my axles back in. I still have to torque those. Those weren't too difficult getting in. The control arms kind of suck. I wish I had some better leverage on that. There's no oil in the transmission yet, so I got to put that in. I'm going to get everything. I'm not going to assemble everything. I'm going to get to a point where I can get the battery in, get all the air ducting set up so I can start it just to make sure everything works. I don't know how it's going to drive with a lightweight flywheel on the stock clutch. There's not really any torsional dampeners in that system now, so it's probably going to be like a really harsh engagement. Here's the old clutch. So, you know, it's dual mass. Inside the dual mass you have springs all the way around that kind of help cushion the blow of the engagement, so to say. So you see here, if I look at the center, I don't know if I can show it, but there's a slight movement. There's springs all the way around in here. This had 90,000 miles on it. It didn't look too bad. I mean, I did towing with this, so I towed my track bike to the racetrack. That was like, you know, 1,200 pounds. There's a little bit of bluing there. I had a little bit of clutch chatter, so I imagine that's what that was from. There was also a little bit of discoloration on that one. But yeah, so I just went with the stock clutch again. There's no torsional dampeners around here. So I think it's going to be pretty harsh engagement. I mean, I can slip the clutch more. I got a pretty good clutch foot. So some people, you know, if you're not good with your clutch engagement, you might not like this setup. Getting rid of the, you know, dual mass flywheel and going to a lightweight flywheel that less weight. It's going to want to stop quicker. You know, it's hard to stop a lot of mass in motion, so naturally the clutch will slip. So if this doesn't cause the clutch to slip, then I have to do that with my foot instead. So I'm gonna continue working here, get everything back together, and then I'll make a final section after I get everything back together and it's running okay. Oh, here it is. It's all done. Everything went back together pretty smoothly. I went for a test drive, and the only problem I had was one of the charge pipes blew off. Other than that, everything seems to be working really well. I mean, the thing just pulls around the turns now. I highly recommend getting a limited slip differential. The lightweight flywheel, I didn't have really any problems with clutch engagement. I mean, you just gotta slip the clutch more. I'm pretty used to it. I've always been pretty decent at smooth takeoffs with a clutch. So, I mean, if you're smooth with the clutch, then this won't be any big of a difference. So, a couple final thoughts. been about 2 weeks now, and I gotta say, this upgrade to LSD is probably one of the best things I've ever felt on this car. I mean, this thing just hooks in the turns. Before, it used to run wide, especially in wet conditions. I mean, if you own a Focus ST and you're going around a corner and you punch it and the road's wet, you'll know what I'm talking about. With this, it feels like it's an all-wheel drive car, and it's on rails. I couldn't believe how big of a difference a limited slip differential, an actual true limited slip differential, not that electronic crap that Ford put in this. I wish they would have put in a mechanical limited slip from the factory, because I mean, it just turns it into, I think, what this car should have been. The only other thing that I have to say is, so the lightweight flywheel, I love the feel of the lightweight flywheel. I always rev match my downshifts, and it's just a lot easier with a lightweight flywheel. You don't get the hang as much, and you can blip the throttle a lot lighter. Before, I'd had to hit the gas pedal a little bit more with more effort, and sometimes you'd miss it and you get that lurch. Other than that, the lightweight flywheel creates that classic gear rattle noise. If you don't know what that is, so that dual mass flywheel and those torsional dampeners in the clutch and flywheel, they help to buffer the firing impulses of the engine from the transmission and smooth out the transmission. So what will happen is, with a lightweight flywheel, it's not buffering those firing impulses, so you are constantly unloading and loading the transmission a little bit. So you'll get this gear rattle. It'll sound like I don't know, like someone's rattling some bolts in a tin can or something. It's a little annoying at first, but I think the benefits outweigh the negatives there. So if you're thinking about going lightweight, especially with a stock clutch that has no torsional dampeners on it, it's something that you want to be aware of. Maybe if I go to an aftermarket clutch, that gear rattle might go away a little bit. But other than that, super happy with the LSD. If you're on the fence about getting one, I'd get one way before you ever drop $2,000 in wheels and tires. Wheels and tires look great, but when you're ripping through the turns, that LSD will help you a lot more than any of those tires or wheels can. I hope my video was helpful in setting the preload. I know I didn't show everything with the transmission taken in and out, but there's videos for that. If you can get the transmission out, if you can't get a transmission out, then you shouldn't be opening up the transmission to do preload. But that's just my opinion. So thanks for watching. Like the video, subscribe. I'll be having more videos on my Focus ST and other stuff I do with cars. So thanks for watching.